After talking about phosphorus and potassium, we will now give some general ideas about fertilizers. This lecture is based on chapter 23 of our book called Fertilizers. What are fertilizers? Those are inorganic or organic products that are used to provide nutrients for plants. They are regulated by a European directive and might be classified according to different criteria. In principle, we consider primary nutrients. Fertilizers are those products that provide primary nutrients or secondary nutrients. Primary nutrients are nitrogen, phosphorus, and potassium. Secondary nutrients are calcium, magnesium, and sulfur. Sodium is also an essential nutrient and is considered a secondary nutrient for some C4 species. We have also micronutrients that are boron, cobalt, copper, iron, manganese, molybdenum, and zinc. We can distinguish fertilizer application considerations as to when to apply fertilizer, and we distinguish between pre-planting applications, the so-called basal fertilizer applications, and we can also apply fertilizers after planting, and then we talk about top dressing if we apply on top of the crop, or side dressing when we applied it side by side with the plants. This would be a basal application over cast application. This would be a top dressing of urea over cotton. The cotton plants are small, but this is around 1 month after emergence of the crop. And this is a side dressing of liquid nitrogen on maize. But we can also distinguish on how to apply fertilizer. We can apply it manually. We can use machines, so-called spreader fertilizer spreaders, or we can apply fertilizer along with irrigation, the so-called fertigation. If you are interested, you can read chapter 27 of the book. We can also distinguish, depending on where to apply the fertilizer, as localized. For instance, we already talked about the banded application of phosphorus or potassium, or applied to the whole surface. This is the usual way of applying nitrogen. And we can also apply either in the soil or as a foliar application of the fertilizer. The global use of fertilizers have changed in the past 20 years, and the trends indicate that there is an increase in phosphorus use in developing countries and a decrease of phosphorus use in developed countries, like in Western Europe or the United States. But in Asia, the amounts of nitrogen are increasing, the amounts of phosphorus are increasing, and the amount of potassium are increasing. In Africa, there is still much improvement to do because the use of fertilizers is very small and hasn't changed much. In America, in South America, the amounts of nitrogen have increased a little bit, but the amounts of phosphorus or potassium have not changed much. We can classify the fertilizer according to different criteria. For instance, we can distinguish inorganic and organic fertilizers, or depending on the composition, we can distinguish among straight fertilizers are those that only contain one nutrient. Compound and complex fertilizers have more than one nutrient. They can be binary when they have two nutrients, the NK NP or NK or PK, or ternary when they have nitrogen, phosphorus, and potassium. They are also called complete fertilizers. We can also have fertilizers with secondary nutrients or micronutrients. In that case, they would have either nitrogen, phosphorus, or potassium, plus either calcium, magnesium, sulfur, or one or more micronutrients. According to the physical presentation of the fertilizer, we can distinguish between solid fertilizers, and they can be presented as powder. They are not very common. Crystalline, usually the salts. For instance, potassium chloride has a crystalline structure. And then the most common are granules, pelletized, or macrogranules. For instance, urea, monoammonium phosphate, and many other solid fertilizers are presented within this category. We can also have a fluid presentation, and this can be a solution fertilizer, for instance, a solution of urea, or a suspension. There is only one case that has a gaseous physical presentation, and that is that of anhydrous ammonia. The most important fertilizer properties in the case of physical properties are the hardness, the density, the fluidity, the humidity, and the particle size. And within the chemical properties, we have the solubility, the reaction in the soil that can be acid if it causes acidification, or basic if the opposite occurs, the salt index if the fertilizer increases the salinity of the soil, or the hygroscopicity, which is the absorption, the capacity to absorb air humidity. Problem with if the fertilizer has a high hygroscopicity, then it will absorb the air humidity, and then it will lose its structure. But one very important property of the fertilizer is its nutrient concentration. In general, or classically, the nitrogen and the micronutrients are expressed in elemental form. But classically, phosphorus, potassium, calcium, magnesium, sodium, and sulfur, as expressed, the concentration is expressed as oxides. That means that we, instead of using elemental K, in many situations we will find K2O. Instead of using elemental phosphorus, we usually find the concentration expressed in units of P2O5. Or for calcium, calcium oxide, magnesium oxide for magnesium, sodium oxide for sodium, or sulfur oxide for sulfur. The trend and my advice is try to express all in elemental form. For instance, when we talk about a 15-15-15, this is a very common fertilizer. So many farmers would be talking about 15-15-15. And this 15-15-15 has 15% of nitrogen. Remember, nitrogen is expressed as elemental nitrogen. But it has 15% of P2O5 and 15% of K2O. What is the meaning of that? Let's calculate what is the concentration of elemental phosphorus. If we have 15% of P2O5, that means that we will have 62 kilograms of phosphorus in 142 kilograms of P2O5. This is by just considering the atomic weight of phosphorus or oxygen. Therefore, 15% converts to 15% of P2O5 converts to 6.5% of elemental phosphorus. If we apply the calculation to potassium, 15% of potassium is converted to only 12.45% of elemental potassium. So, fertilizer manufacturers are very happy selling you 15, 15, 15 because it says, well, it has a concentration of 15% of phosphorus. Well, actually, it has 15% of P2O5. It has only 6.5% of phosphorus. The remainder from 6.5 to 15 is oxygen. So the fertilizer producer is selling you oxygen by considering the concentration in P2O5. Therefore, it's better to express concentration in elemental forms, even if you have to convert what you see in the label of the fertilizer. So commonly in the label of a fertilizer, of a sack of fertilizer, you will find the concentrations expressed as P2O5 or K2O. First of all, always convert to elemental composition. In the tables in the book, you will find the concentrations expressed in phosphorus, elemental phosphorus, and elemental potassium. What are the most common fertilizers that we can use? Well, if we consider straight fertilizers, let's start with fertilizers containing nitrogen. And for nitrogen, we have two main groups. One group containing nitrate and the other group containing ammonium. The straight fertilizers containing nitrate are, for instance, calcium nitrate, sodium nitrate, or magnesium nitrate. But remember, nitrate is an anion that is quietly soluble in water. That is good because it will be absorbed rapidly by the plants, but that is bad because it may be washed out, in other words, leached from the soil profile. Therefore, it is not advisable to put nitrogen before planting because then it can be leached. It is better to use it after planting when the plant needs it. In other words, nitrate should be used for top dressing or side dressing applications after planting. We have also fertilizers, straight fertilizers with ammonium. Ammonium has an advantage over nitrate, and it is that it is absorbed by the soil exchange complex. In other words, it will not be leached because it is not in the soil solution. However, it converts rapidly if temperature is high enough. It will convert rapidly to nitrate in the soil by nitrification. Therefore, we can use ammonium fertilizers as a basal fertilizer in winter. So we can use this before planting and incorporate it into the soil when we incorporate phosphorus and potassium. Examples of ammonium fertilizers: ammonium sulfate, anhydrous ammonia, which is a gas, so it has to be injected into the soil, or pressure solutions of ammonia that requires also special equipment for applications. These are not common in Spain, are more common in the United States. Ammonium sulfate is common here. Then we have some fertilizers that have both nitrate and ammonium. So they can be used basically for top dressing applications. We have ammonium nitrate and ammonium nitrosulfate. One important characteristic of ammonium nitrate is that it can be used for producing explosives. In the past, they were commonly used in mining by mixing ammonium nitrate by fuel. You get ANFO, AMPHO, which is an explosive and has been used frequently by terrorists all around the world. That has led to strict regulations because of the terrorist threat. So nobody, so it is not free, it's not easy to buy ammonium nitrate without a specific control of the buyers and the sellers. Sometimes what the industry has been doing is to mix ammonium nitrate with other products that reduce the probability or the efficiency of the fertilizer to produce explosives. We have a third group of straight nitrogen fertilizers that include urea and calcium cyanamide, but calcium cyanamide converts rapidly to urea in the soil. So basically it's the group of urea. And urea can also be associated to the group of ammonium because if there is water in the soil, it will be hydrolyzed to ammonium very rapidly if the temperature is high enough. Urea is highly soluble, is very popular and very cheap. So it is widely used as a straight nitrogen fertilizer. It is better to incorporate urea because if left on the soil surface, it can be lost by ammonia volatilization. It can be used both for basal applications because it works as an ammonium fertilizer and as a top dressing if we can incorporate it into the soil with irrigation, for instance, because it is highly soluble. It can be also applied as a foliar spray and it can also be used in fertigation. So urea is a very convenient fertilizer product. It is very cheap and it's very versatile. It can be used in many modes of application. In the case of straight phosphorus fertilizers, usually the main characteristic to be considered is the solubility, and the solubility is measured in water or in ammonium citrate. The solubility in ammonium citrate is measured because it mimics the fact that in the rhizosphere, the acids exuded by the roots will create a lower pH area where the phosphorus, the phosphate, can be better acquired by the plant. Therefore, we not only consider water solubility. The most frequently used fertilizers for phosphorus are those that are mostly soluble in water, and that includes superphosphates, which are less than 10% of phosphorus, of elemental phosphorus, triple superphosphate, which has around double of the previous, it's around 20% phosphorus, and in fertigation, phosphoric acid or superphosphoric acid. But the main straight phosphorus fertilizers that you can use are superphosphate or triple superphosphate. One advantage of superphosphate is that it has also calcium. So in cases where you need to add calcium, that's a good choice. The straight potassium fertilizers have the important property that they are soluble in water. Potassium sulfate has a lower solubility and is more expensive, while potassium chloride contains chloride as it is, and that can be a problem in some crops and some soils if we can have potential problems of salinity. Compound and complex fertilizers are those that have at least 2 nutrients. And within this category, we have the binary nitrogen phosphorus class, and that includes monoammonium phosphate, MAP that has between 10 and 12 nitrogen and 48 to 60 of phosphate. Then we have the ammonium phosphate, and this is the most important phosphorus fertilizer in the world. It takes 40% of phosphorus application around the world, and this is 1846 for phosphate. Then we have very commonly, or many times, the farmer use ternaries NPKs that are mixtures of straight and compound fertilizers. There is a wide range in grades and presentations, and they are always used as basal broadcast applications. So before planting, these are the usual type of fertilizer that the farmers will use. For instance, the 15, 15, 15 that we saw before. Remember that 15 is not 15 phosphorus, but 15 phosphate, and 15, and this 15 doesn't mean 15 potassium, but 15 K2O. We can use also organic fertilizers, and they can be from animal origins as animal waste, slurry, which is liquid animal waste, dung, solid and plus liquid, farmyard manure, and poultry litter. Farmyard manure is basically solid, and poultry litter has some fraction of water with it. Within the farm, we can get crop residues, pruning residues, green manure, or garbages that we can use for fertilization. But we can also acquire external fertilizers, including peat, compost, for instance, that produced from organic urban residues, and byproducts or waste of the food industry, like blood or bones that are used in organic agriculture. Organic fertilizers have a lot of drawbacks. Well, and one important drawback is that usually we don't have much availability of organic fertilizers to supply agriculture. Therefore, we are forced to use inorganic fertilizers. But another problems with organic fertilizers are the high water content and low nutrient concentration. Therefore, if we need to supply enough nutrients to our crops, we need to apply huge amounts, several tons per hectare of organic fertilizers. Another problem is the uneven distribution. The nutrients are not easily to distribute when we use organic fertilizers. It is unavoidable to have high losses of volatilization of ammonia. So a large fraction of nitrogen will be lost by volatilization of ammonia. And also, it is common to have important losses by leaching from organic nitrogen in organic fertilizers. They generate bad smells and potential chemical and microbial contamination of waters. It includes weed seeds, pathogens, and insect larvae. Therefore, when you are adding organic fertilizers from other farms, you are moving a lot of biotic problems to your farm. The fermentation in the field of fresh organic residues might produce phytotoxic compounds to plants and low oxygen concentration, and that can be phytotoxic too. Also, when residues of high carbon-nitrogen ratio are decomposing, then that will promote nitrogen immobilization. So we have to be careful when we add either residues or organic fertilizers with a high carbon-nitrogen ratio. In other words, when they are poor in nitrogen, because that will promote nitrogen immobilization in the soil. This is a table that you can find in the book where we have compiled the amount of manure and the equivalent amount of nitrogen, phosphorus, and potassium per animal from different species. Dairy, beef, dairy is for milk production, beef is for meat production, swine, pork, poultry, chickens, for instance, horse, sheep, goat, cabra, rabbit, conejo. And these are different types of these animals. Cow or heifer, this is an older, this is a younger. Cow, feeder, stocker, depending on if you are growing them for meat, and depending on the stage of growth of the animal, this is the amount of manure that you can produce per year per animal. You see that the amount of manure produced is very high with cows. These are largest cows. And the total amount of kilogram of nitrogen, phosphorus, and potassium that you can produce per animal grown.